Hello everyone, my name is Alfonso and I also work with Marco in IPC, but today I come to tell you a story and a work in progress. And this is the runway. Okay, so I'm going to talk a path towards customizable blockchains, and I'm going to justify why we may need this. Because many of you will be thinking like, why customizing blockchains? Like there are a lot of blockchains out there. Why not use them as they are? And I told you that I'm going to tell you a story, and it's the story of IPC. Because IPC has a lot of history. Like Juan was thinking about it in 2016. We've been working on it for 2.5 years, and we've explored a lot of stuff. And this was the goal. Like the main goal is bringing Web to scale into Web3 and having a substrate that will support this kind of loads in blockchains. And this means like fast, optimistic local finality in the line of what Marco was saying, Web2 scale throughput, as Juan was mentioning, partition tolerance. So there's a lot of properties that we need for IPC to work and like to be able to support Web2 into Web3 infrastructure. And there's our proposal, which is IPC, and is this idea of deploying hierarchical subnets. So to have a rootnet, in our case is Filecoin, and be able, as a user, to deploy a new substrate that fits the needs of our application, either high throughput, fast finality, or any other thing that we may need. And as we're building this, so IPC has suffered several stages. There's a first stage of the MVP that was built on top of Lotus, and then a second stage where some off-chain mechanics were working on top of Lotus and so on. And there has been a lot more because the problem is that once you start figuring out like how to change the substrate and make it configurable to the needs of an application, it's really hard to have like a single peer implementation that fits all of our needs. And actually we did a lot of tests. So first, like our reference implementation, our first reference implementation was using Lotus. And the problem with Lotus is what Marco mentioned, like there we have a longest chain consensus algorithm. If we want to fit other kind of consensus algorithms, like for instance, instant finality or BFT, the code architecture is not fit for it. So it's really hard to like have this configurability at a client level. Then we said, okay, let's try Forest. Let's see if we can, but same problem. Like it's implemented for a longest chain protocol. Integrating BFT was hard. And then we went to the space and we said like, what others are doing out there? And we, of course, came up with Polkadot substrate, but it didn't have all that we needed because it's not content addressed. It couldn't run the FVM. The FVM is a requirement for us. We'll see in a moment. So there were certain constraints. And that's how, I think it was 8 months ago, we started our own like test of having our peer implementation on top of Comet BFT and Tendermint. And the idea was like, okay, let's figure out the right interface to consensus and let's build the FVM, IPLD, all the blockchain on top of it so that we can swap in and swap out what we need. And this idea of like having the right interface and on top of the right interface, like a peer implementation that allows us to plug in and plug out stuff is how we figure out, okay, we may need something that is configurable. We may need something that is customizable so that anyone can come up and say, hey, I need a longest chain protocol. I need a mempool that does this strategy and have a way to replace them as the applications and the users need them. So yeah, this is a bit of like the things that we wanted: content addressing, configurable, custom runtimes on top of the FVM, custom consensus. We wanted to run anywhere. So there were a lot of things that we wanted out of our peer implementation that couldn't be done with the ones that we tested. And it's not that Lotus is bad. It's just that it's really fine-tuned for Filecoin and not to play with all of this configurability. And that's when we said, okay, let's try and build what we called the yellow box, which is this single code base that would allow us to have all of these different pieces so that developers could, like, of course, this is in the scope of IPC. Our original problem was IPC, but like the idea is that let's have a single code base that we can use to configure our blockchain to our needs, fast consensus, whatever we need, different mempools, different chain views. We even came with this architecture of what it would look like and have like this marketplace of the different models to customize our pre-implementation. then we realized we can make it even better, like to support all of these new fancy consensus with checkpointing, with like garbage collection, and so on. And we kept looking at the space and saying, okay, let's see what is out there. Like, is this good enough? Are others trying the same as us? And then we realized something. We have the FVM, and like FVM is looking to be this hypervisor for blockchain runtimes, and kind of like an OS, an operating system for blockchain. So, and this is one of our requirements, like content addressing, FVM, P2P, or 3 requirements. So why not trying to take this to the extreme? And that's how the idea of the yellow runtime, like pushing as much logic as possible to the FVM, came up. And this is basically like the idea that we have in this yellow runtime project. This is a work in progress project. This is more of an idea than anything else. We are hoping to kick it off soon. But I used to give you the this inception and why we think we need this in the scope of IPC. So the idea is to push as much as we can of the blockchain logic into the runtime as actors. So now we have the miner actor, we have the market actor, we have all of these actors that are specific for certain, like, let's call them application-specific or Filecoin-specific things. The idea is to generalize that, to have a lot of the logic inside the runtime, so that having a customizable blockchain would be just running the FVM with the actors that we need. Like, there could be a marketplace and say, I need this mempool, I need this consensus, I need this specific state tree to represent my state. And you could, like, with a simple template, decide what are the actors, actually with just a bunch of CIDs, define what type of node you want to run. And yeah, so this is basically the idea, like to have WASM blockchain modules in the FVM, and then of course have an IPLD block store and P2P. So like have a slim peer implementation that puts all of the load into the FVM and having like all of the blockchain logic into the FVM. And something like this has a lot of really nice consequences if we manage to do them, because everything would be in the state tree, like the actual code of the blockchain will be in the blockchain, which means that like syncing from the network would be like downloading the code for the blockchain and then syncing from the network. And yeah, here, I mean, I'm really excited about this idea. Probably I'm biased, but like the cool thing is that it would allow to integrate blockchain capabilities into any application, because it's like, if I have an application that can run the FVM, eventually we could have like clients, we could have like browser run blockchains, like it could enable a lot of things that we weren't able to do now. And of course, this is, and I think that Juan have been mentioning it a lot, these Unix of blockchains. This is the idea of the content addressing and like the Unix of blockchains, because we would have like the operating system being FVM and then all of these models on top of it. And like, of course, there's a lot of things to figure out, like syscalls, like access rights. This is not easy, but like this is the idea that we are pushing, because now it came the need. Before it was more of a like long-term idea. Now we really need it for IPC, because like we haven't found something that would allow the configurability that we need for blockchains. And yeah, like the idea is that on top of FVM also we could support any kind of runtime, like Fluence, even one that I'm really excited about, IPVM. We could run over FVM the IPVM, so that not only blockchains, but like the FVM could be this hypervisor of like other content addressed stuff. Let's call it stuff. And actually, IPVM would be great for all of these syscalls with IPFS, syscalls with, say, K-runtimes, downloading the code. So it kind of fits nicely, at least from a conceptual level. And like this is a bunch of the use cases that I could see unlocking, like for instance, embedding blockchains in a browser, because like once we have FVM, as long as you can run FVM, you could, why not, integrate at least a light client into the browser, what would remove all of the RPC APIs, all of these infras, or it will simplify a lot, like the decentralization of all of these pieces, or heavy pieces of the blockchain space right now. We could have like peer implementations that sync with more than one network, because like we could say, okay, this is my FVM, I want to run like these syncers, like the syncer with Ethereum, the syncer with Filecoin, and like this custom subnet. And of course, like coming back to our, okay, I have more use cases. So yeah, custom syscalls. Like the other thing that is really cool is that the FVM, every new update that the FVM has, like custom syscalls, like there are new syscalls that come out. The blockchains would be able to adopt them for free, because it's just like updating the FVM dependency. So yeah, like we can chat. There are a bunch of use cases here that I think that will be cool. Unfortunately, like we need to first build this, but there are a lot of like, if we have custom syscalls, we could have GPU-specific subnets. So have a way of hook access to GPU jobs execution as a part of the blockchain runtime. So there are a bunch of really cool stuff here that we could do. But yeah, like coming back to our original problem, our problem was like we cannot find a pure implementation for IPC, so that is configurable enough for everyone to be able to use it. And like actually, thank you, Raul, for I just copy pasted it here, but this is the idea that we have with the Yellow runtime and IPC. So have a way of like defining, like first, it would be great if we have a pure implementation that can run anywhere, so that we can have subnets from like really heavy Filecoin peers to more light browser or even mobile executed runtimes. And then the idea is that right now, I mean, if you've tested IPC, one of the problems that we're seeing is that the UX is really rough because of all of these moving parts and all of these things is super rough. And I was getting really frustrated while building this, like it shouldn't be this rough. And the idea is that with these, if we have this way of like configuring and easily having a marketplace of models for blockchain, we would allow to have like these fancy UX where we just, the same way that we do our infrastructure as code, we could do blockchain as code, where you just define what you need for your blockchain node, do IPC create or IPC deploy subnet, and avoid a lot of the heavy operator like steps that we can chat in the IPC workshop, but like, of course, this is the main criticism that I have to our tech, is rough. Like, there are a lot of moving pieces because you have to worry about the operating the blockchain, all of the deploying the subnet. As a user, I don't care. Like, I just want to deploy a subnet and I want something like template, a Terraform template that would allow me to deploy the server, just copy paste it here and run my application. So yeah, and when can I try that? That's a good question. So we are doing a huge rework of IPC with Fendermint, like this application, this Comet BFT application with FVM that we're hoping to replace for something else in the future. But the idea is that we're moving into that, like trying to make UX more seamless through this Tendermint interface so that eventually when we have this yellow runtime, we can replace it on top of the wrapper that we have. And yeah, people don't like yellow runtime, sorry. I didn't have any other name. Yeah, I'm sorry. So yeah, and basically, of course, this is a work in progress idea. This is like the vision for the IPC substrate. We cannot build this alone. So if you have any feedback, any feature request, I don't know. Let's discuss. We need to build it. Thank you.